Hey, Luke here from Technicamps, and I'm going to be running through the session 3 tasks, so 3.1 all the way up to, I guess, up to challenge task 3.5. Okay, so task 3.1, type out and run the following Python program: a equals 20, b equals 46, c equals a plus b, print, the sum is c. This program calculates the sum of the numbers 20 and 46. So let's type out and run that following that Python program. So we go into Python, file, new file, a equals, and I've already forgotten the numbers, 20, b equals 46, and then c equals a plus b. C equals a plus b. And then we have a print statement which says print the sum is. With a capital T, why not? The sum is, and then the value C. So, comma C. So if I save this, so file, save as, I'm going to save this as task 3.1, and run module. We get 66, and 20 plus 46 is 66. That makes sense. That's good. Hopefully the program is running correctly. And then we can continue, which says modify the program so it sums up numbers 20, 18, and 46. Okay, so I need 20, 18, and 46. So I'm going to change b to be 18, and then I'm going to have a value c, which is 46. Okay, and then I'm going to have to change this variable name, so I'm going to call that one d. And I want to sum up a, b, and c. So a plus b plus c, lowercase c. And then I need to print out, not c this time, but I need to print out d. So I've got a is 20, b is 18, c is 46. D is a plus b plus c, and then I'm printing that sum out. Okay, so again, file, save, run module. And this time I get 84. That should be good. So that's problem 3.1 done. So I'm going to close that, and I'm going to read task 3.2. So task 3.2, write a program that asks the user the following questions. What is your name? What is your neighbor's name? What color is your neighbor's hair? Your program should store the user's answers in variables. Next, the program should print the following. Hello, your name. Your neighbor is blah. Their hair color is blah. And for this task, you must use a single print statement and format specifiers. Okay, an escape character can be used to embed a new line within a string. Nice. Okay, so this one is focusing on our inputs. So first thing we're going to get is the user's name. So username maybe equals input. What is your name? Question mark. Okay. Now I could at the start here put a string function cast in, but remembering that the input is by default cast as a string, I don't need to do that. Okay. Using a cast call will be more important in later tasks. So we get the user's name, then we get the neighbor name equals input. What is your neighbor's name? Question mark. Okay. And then we get their hair color, right? So neighbor hair color. Okay, so we're using sensible variable names. I know in the first one we didn't really use sensible variable names. A, B, and C, or A, B, C, and D are not particularly great variable names. These ones are better because they kind of give an indication of what values will be stored inside them. What is your neighbor's hair color? Okay. And then the program, it asks us to print, hello, your name, your neighbor is blah, and has hair color blah, right? But it's asked us to do that in a single print statement using format specifier. So we're going to print hello, and it's %s. Then we're going to have a new line, and you might remember that the new line is \n. What was it? Your neighbor is your neighbor is %s and has %s hair color. And has color hair. Okay, we'll do it that way around. And has has blah. Okay, I'll change this one to hair. Not very good at creating my own sentences. Hair is followed that. Perfect. Okay. So that could be my print statement, but I need to tell it what these, what variables to use in these specifiers. So we're going to have username as the first one. Then we have neighbor name as the second one, second variable being put in here, and then the third variable is neighbor hair color. Okay, so hopefully I've not made any spelling mistakes, so that close that parentheses and then close the overall print statement. So file, save as. I'm going to save this one as task 3.2. And I'm going to go run module. Hopefully I've not made any spelling mistakes. There's some invalid syntax here. Ooh, I've made a mistake here. Run module. Okay, it doesn't like the way I've done this. Run module. Okay, cool. So no comma is needed there. Okay, so hopefully you saw that if I include that comma, right, if I include that comma here, like I would do if I was just using a normal variable, and I press run module, I get a syntax error. Okay, when I'm using the format specifiers, I don't need this comma in. If I remove the comma and then run the module, it's going to ask me to save, and this time I don't get that error code. So that comma isn't needed, and actually causes a syntax error. So what is your name? My name is Luke. What is your neighbor's name? My neighbor's name is Jeff, but Geoff. And he has brown hair. Hello, Luke. Your neighbor is Jeff and has brown hair. Perfect. And it's done the new line and it's used the format specifiers. Okay, so that was task. Okay, so that was task 3.2. So now we're going to move on to task 3.3. Write a program that prompts the user for two integers and then prints the sum, the difference, the product, the average, the distance, the maximum, and the minimum. Okay. And if we go to the next page, I think it gives us a little bit more information. Make sure your output is easily readable. It should be clear what each number represents in your output. Hint, Python defines max and min functions that accept a sequence of values, each separated with a comma. Perfect. So we don't have to declare any interesting max or min functions. We can just use the inbuilt Python ones. Okay, so we're going to have file, new file. So we're going to get the user to enter two numbers, right? So we're going to call the first one number1 equals, in their integers, so int input, please enter the first number. Okay, and then we're going to have a number 2. And again, this is an integer. Input, please enter the second number. There we go. Okay, so now we've got our two inputs. I'm going to have a bunch of variables maybe to, hold their sum, hold their difference, hold all of the things that were requested. And the things that were requested were sum, difference, product, average, distance, maximum, minimum. So I'm going to have a sum variable equal. Oh, I can't use sum. It's highlighted purple because that's a reserved word in Python. It's the name of a function. So I'm going to say sum of numbers. There we go. Equals number 1 plus number 2. Then the next one was difference. Let's call this one difference of numbers equals difference of numbers. So the distance is the absolute value of the difference, whereas the difference can just be one with the other taken away. So I guess this can be a negative number. So number 1 minus number 2. Okay, so it's the difference of the numbers. The product of numbers equals number 1 times number 2. The average. Okay, so average of numbers is going to be number 1 times number 2, and that whole thing is going to be divided by 2. So divided by 2. Okay. Distance, the absolute value of the difference. So distance of numbers equals abs. So we're using that a function here, the absolute value, abs of number 1 minus number 2. Okay, so that's distance. Then the max of numbers equals max number 1 comma number 2, and then we've got min of numbers equals min number 1 comma number 2. Okay, so we can go through this and just check them all, make sure that we're happy with what we've written out. So we've got them to input the first number, input the second number. We've got the sum as number 1 plus number 2. Difference is number 1 minus number 2. Product is number 1 times number 2. Average is number 1 times number 2, all divided by 2. Distance is the absolute value of the difference. Max is the maximum, and min is the minimum. Okay, so now we're going to get our print statement out, and we're going to use format specifiers to print this all out. Does it ask us to use format specifiers? Make sure your output is easily readable. Okay, so it doesn't ask us to use format specifiers, but maybe we will anyway. So print sum, and then let's have our %d, because it's an integer, and then we'll have a new line, difference, and then we'll have our %d, because again that's going to be an integer, and then a new line, product, which again is going to be an integer, %d, new line. Now we get to our average, and our average might actually be a floating point number, because if we have an odd number and we divide it by 2, we're going to have like a 0.5 line hanging around. So this time I'm going to use %f for floating point, and then new line. Distance is going to be a whole number value, so I'm going to use %d. Let's just make sure I'm using the same formatting. New line. Max is going to be another %d. And then new line, and finally min, which again is going to be an integer, so %d. Okay, so I can close my quotation marks there, and then I can have my % symbol and slowly call all of my variable names. So I had sum of numbers, difference of numbers, can't remember what the next thing was, sum of numbers, product of numbers, average of numbers, distance of numbers, max of numbers, and then the last one I think was min of numbers. Okay, so close the parentheses for that, the specifiers and the variables that I'm using, and then close the print statement parentheses, and then that should be everything. So let's go File, Save As. This is task.3, so task 3.3. Save that. Let's try and run it. Hopefully I've not made any spelling mistakes. It seems good so far. So let's just check it. Let's start with 2 really simple numbers, so like 1 and 1. Okay, so 1 plus 1 should be 2, 1 minus 1 should be 0, 1 times 1 should be 1. We should get an average of 1, we should get a maximum of 1, we should get a minimum of 1, we should get a distance of 0. So we've got a sum of 2, which is 1 plus 1, fine. Difference 1 minus 1 is 0, perfect. 1 times 1 is 1. 1 plus 1 divided by 2. Ooh, what's 1 plus 1? Oh, that shouldn't be a multiply. That should be an add. Haha, we made a mistake. So I'm glad that we checked this, because our average shouldn't be number 1 times number 2. It should be number 1 plus number 2 divided by 2. So it's a good thing to test your code by using some entries. So we made a mistake on this average of numbers line, which I'm sure if you're watching the video you were screaming through your screen at me. So I've made that change now, and let's file, save the program, and run the program again. And let's try some different numbers this time, so 2 and 4. So 2 is our first number, 4 is our second number. 2 plus 4 is 6. 2 minus 4 is minus 2, fine. 2 times 4 is 8. 2 plus 4 is 6, divided by 2 is 3, fine. The absolute value of the difference between them, so 2 minus 4, but then turned into a positive value, is 2. The maximum number is 4, the minimum value is 2. Awesome. The only thing I might want to change is this average has quite a lot of decimal places, so maybe I want to do something like 0.0, maybe, something like that, and change the specifier, and then if I, maybe not 0.0, 0.1, because we may have some interesting things, and then run the module, and let's choose some kind of interesting numbers, so let's choose an odd number and an even number, so 5 and 4, and then we've got a nice average without all of the points after the decimal place. Okay, cool. So that was task 3.3. You might have noticed that I made some mistakes in it. I had to go back, I had to add extra little bits in. Okay, so it's always worth testing your programs and on values that you know the answers to, just to make sure that you get the right values out and that your program is working properly. Okay, task 3.4. Write a program that calculates the weekly cost of beer for a student. A very important program indeed. Your program should ask the user for the price per beer, how many beers they purchased that week. The program then should calculate the total cost of beer. For this task, you should print the final cost to 2 decimal places using format specifiers. Don't worry about using the pound symbol. Okay. So new file. So we need to get the number of beers. So number of beers equals, and you can only have a whole number of beers, right? No one buys half. Oh, I guess you could have half a pint. We're going to go with whole number of beers. Maybe they're buying like cans of beer rather than pints of beer. So number of beers, we're going to say is a whole number. How many beers have you had this week? Okay. So we're going with a whole number of beers. But the price of beer could be a floating point number, right? Your beer could cost £2.15, or it could cost £1.99. It depends on what beer you're buying, but it could be a floating point number. So, what is the price of a beer? And we'll get them to enter that for us as well. Okay, so number of beers is an integer, price of beer is a float. So then we're going to have our total beer spend, I guess, is our third variable, which is going to be the number of beers we have times the price of each beer. Right? And that'll give us our total amount of money that we've spent on our beer, and then we're going to print that out. So you spent percent. We only want 2 decimal places, right? Because if we're talking about currency, we only really go to 2 decimal places, so 0.2f. So you spent that much money on beers this week. Okay, and then we've used total beer spend as our variable. Okay, so let's save this. So file, save as, task 3.4. And let's run it. Okay, let's say I've had quite a quiet week and I've had no beers, but I know that each beer costs about £2.99. I've spent £0 on beer this week, and that makes sense because I haven't bought any, even though they cost some money. let's say it's a heavier weekend, maybe the football or the rugby's on, and I've had 7 beers this week. And the price of beer is, because it's an international day, the price of beer goes up. It's £4.45 for a beer. So according to this, I would have spent £31.15 on beer this week. Again, it's worth going through and checking the maths on the calculator just to make sure that this is the value we expect out. But that seems to work, and the way it's formatted is quite nice as well. Okay, then we get to the final challenge task. Write a program that prompts the user for a radius of a circle and then prints the following: the area and circumference of the circle with that radius, the volume and surface area of a sphere with that radius. Okay, file, new file. So the first thing that we need to do is get the user to tell us the radius. The radius of a circle could be a whole number, but it could also have a decimal place. So we're going to have user radius equals float. Input, please enter the radius. Okay. So now that we've got the radius, we need to do some things with it. So I went online to look up some formulas. So this one tells me that the area of a circle is pi times radius squared. So area of circle equals... Okay, well, I don't know what pi is yet. Times radius. And hopefully we remember that double star is exponentiation. So double star 2 is squared. And then we need circumference of a circle, which is here. Circumference of a circle is pi times diameter, where diameter is 2 times radius. Okay, so circumference of circle equals, okay, our pi value, which we haven't gone and got yet, times 2 times the radius. And the radius we've got is user radius. So let's change this one as well to user radius. Okay. And then we got asked about the volume and surface area of a sphere. Okay, so I've got some more information here. So the volume of a sphere is 4/3 pi r cubed, and the surface area of a sphere is 4 pi r squared. So volume of sphere is 4 divided by 3 multiplied by this pi value, which we haven't got yet, multiplied by our user radius, where our user radius is raised to the power of 3. And then our surface area is 4 pi r squared. So surface area of sphere is 4 times our pi value, which we haven't gone and got yet, times our user radius squared. Okay, so now we need to get our pi value, and pi is part of the math library. So there are a couple of ways we can do this. There's just importing the whole library and then calling math.pi, or you can specifically import pi itself and just pi from the math library. So I'm going to go import math and do it this way. So I'm going to replace these with math.pi, and this is going to call the pi value from the math library, so that we can use it. And pi is 3.14 whatever. Math.pi. Okay, so that should do all the calculations, and then I want to have a nice print statement, which is going to say something like area of circle, and this could be a floating point number. Let's do this to, let's say, 2 decimal places. That seems like a nice value. Then we're going to have a new line. Spelling is hard. Circumference of circle. Again, nice floating point number to 2 decimal places, and then a new line. Volume of sphere. Let's have that again as a floating point value and only 2 decimal places. And then finally, on our lowest line, of our bottom line, surface area of sphere. And again, we'll have that as a floating point value with 2 decimal places. Okay, and then we just need to shove in all of the variables we've used. So we used, let's look up here, area of a circle, circumference of a circle, volume of sphere, surface area of sphere. Okay, so area of circle, comma, circumference of circle, comma, volume of sphere, comma, surface area of sphere, surface area of sphere, close bracket, close bracket. Let's save this file, save as task 3.5. Okay, and then let's run this and see how it gets on. So please enter the radius. Let's enter the radius of 1, just as a standard. So area of a circle is pi r squared. 1 squared is 1, so we just get pi back, which is good. Circumference of a circle, we should get 2 pi r. If r is 1, we get 2 pi. 2 times 3.1 blah 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 is 6.28, so that's good. Volume of the sphere 4/3 pi r cubed, that seems fine. And surface area of a sphere, we get 4 pi r squared, so we get 4 times pi. And if pi is 3.14, then 4 times that is about 12.57. So that seems pretty good. We can test it again with 0 and see what happens. And we get zeros everywhere because we're multiplying by 0, and that feels good. So hopefully that program works. Hopefully you're a little bit more confident now using format specifiers and also testing your programs. Don't be afraid to make mistakes. If you make mistakes, just try and identify where they are, go back into the program and fix them. I make loads of mistakes when I program. Okay, so that's everything for our challenge task. Our tasks for session 3, from task 3.1 all the way up to the challenge task 3.5. Good luck with the rest of the lectures and the rest of the challenges that you try and do.